Problem number 28.04. The figure shows the essentials of the mass spectrometer, which can be used to measure the mass of an ion. An ion of mass m is to be measured. We are going to find the value of the mass, and the charge q is produced in the source S. So if you see the figure, we have the source S. So from this source, the ions are coming. Initially, stationary ion is accelerated by the electric field due to the potential difference. By applying the potential difference, you are just accelerating this ion. The ion leaves the source and enters the separate chamber in which the uniform magnetic field B vector, which is perpendicular to the path of the ion. So you can see here, when you apply the external potential from the source, the ions are coming out. When these ions enter this magnetic field region, you can see this is a separate chamber, and all these green colored dots are the magnetic field. And what they clearly mention, the magnetic field is exactly perpendicular to the path of the ion. That means the speed as well as the magnetic field are perpendicular. That means the angle between the speed and the magnetic field are exactly 90 degrees. A white detector lines the bottom of the wall of the chamber, and the magnetic field causes the ions to move in a semicircle and thus to strike the detector. So when the ions enters this magnetic field, it will be moving in the semicircle and it is about to hit the detector. And from the starting to the ending point where the ions is going to hit the detector, its distance is mentioned here as x. Suppose the B value is 80 millitesla and the applied voltage V, which is equal to 1000 volt, and the ion value charge, that means the charge of the ion is 1.602 multiply 10 power minus 19 coulomb, strikes the detector at a point that lies at x is equal to 1.6254. So what I told you, when the ions enters this magnetic field, it will be moving in the semicircle and it is going to hit the detector. So the distance from the starting point and where the ion is going to hit the detector, and that distance is mentioned as x, and that value is given here. So now what you are going to do, we are going to find what is the mass of the individual ions, and you have to give the mass in terms of atomic mass unit, and the conversion of the atomic mass unit in terms of kilogram is given here. So finally, once you get the answer in terms of kilogram, you have to give the answer in terms of atomic mass unit. Clear? Okay. So let's write the given first. What is given in the question? The uniform magnetic field is given. What's the value? 80 millitesla. So 80 millitesla, in terms of Tesla, we can write 80 multiply 10 power minus 3 Tesla. And what is the potential difference you gave? Which is 1000 volt. And then the x value, the charge value is also given, which is 1.6 multiply. So okay, let's write the full value. So 1.6022 multiply 10 power minus 19 coulomb, and also the distance from the starting point of the ion and where it's going to hit the detector, and the x value is given as 1.6254 meter, and finally you are going to find what is the mass of the ion, right? Okay, so for this we have to just go back to our theory class. So what we studied, so if you want to take the ion from the source, you are just giving the external potential. Am I right? So when you just give the external potentials, what you are exactly doing, your charge potential energy is converted to kinetic energy. So that means 1 electron volt, that means the voltage applied to the charge. So let's write Q multiplied by the potential. Q you can take, or either you can use E, no problem, both will be the same. So here charge, either you can use the letter E or Q. So that means when you apply the potential to the charge, its potential energy is converted to kinetic energy. That means half mv squared. So I'm going to find the speed first, and after that I'm going to use the radius, because it is exactly semicircle. So if it is semicircle, you can see if it is semicircle, so from the starting to the end you will get the diameter. When you just divide the diameter by 2, you will get the radius, right? So we have the radius formula also. So in the first part, I'm going to find the speed. So what is the speed? You have to rearrange this equation. So what is the speed? So v square, which is equal to 2 q multiplied by caps v. So don't get confused about the small v and the big V, because small v is speed and the big size, that means the caps V is the potential. So 2qv divided by the mass of the ion. So mass of the ion. So inshallah we will apply the values later, because we are going to find the value of the mass. Okay. So now I have to take this. I can just use this value later. So here I am going to take the square root. So what's the value? Square root, both left hand side and right hand side, if you took, you will get square root of 2qv over mass. Now what I am going to do, because this, if you just go back to the circuit, the diagram, not circuit, the diagram, it is in the semicircle. So that means it has the radius, am I right? It is a half of the circle. So we have the formula for the radius. What is the formula for the radius calculation? Just recall what you studied in the theory. So the radius formula is mass of the ion multiplied by the speed of the ion divided by the charge multiplied by the magnetic field. Now what I'm going to do, I'm going to take this V, I'm going to substitute here. If you substitute, what you'll get? We'll get the new formula R, which is equal to M over QB. In place of V, we will get this, right? So 2Q multiplied by big V divided by M. Right? Okay. Now the most important thing, we have to just go back to the diagram again. So your x value is given here. So what is this x actually? So the value of x is nothing but 2 times of radius, right? So if you just see, this is a semicircle. If you just see the semicircle, from this part to this part, this is the diameter, right? And what is the half? Half of the diameter is the radius. So that means if you have 2 radius, for example, from the center to the starting point is R, from the center to the hitting point is R. So your x, which is equal to 2 times of R, am I right? So what I'm going to do, I'm going to use this concept, your x, which is equal to 2 times of R, and then I'm going to take the R, I'm going to substitute here. So what you'll get, 2 multiply with M over QB square root of 2QV over mass. Left hand side we have x, and the x value is already given. So what is our aim? We are going to find what should be the mass of the ion. So if you want to get the mass of the ions, the only option, we can just take this, we can just squaring both the left hand side and the right hand side. So what is the left hand side? The left hand side of the equation is x, and the right hand side of the equation is the full term, right? So I'm going to squaring both sides, squaring the above equation on both sides, on both sides. So if you're squaring, what you will get? You will get, this becomes x square, and this becomes 2, right? So 2 becomes 4, m becomes m square, and then bottom you have q square, and then magnetic field square, and this square root will gone. So what is remaining? 2q, and the potential divided by mass. So now we can just cancel some terms. What are the same terms we have in the top? So we can cancel one mass here, and also we can cancel one charge here. So what is remaining? Therefore x square, which is equal to 4m multiplied by 2v divided by qb square, right? If you simplify this, 4 multiplied by 2, we can just write this as 8m v. So don't, this is not milli, this is mass, okay? So 8m multiplied by v, potential, divided by charge multiplied by magnetic field square. Left hand side we have x square, but our aim, our object is to find the mass. So what I have to do, again I have to remodify this equation in terms of mass. Therefore mass, which is equal to, I have to move the terms. So x square multiplied by q multiplied by b square, because all this term will come to the left hand side of the numerator. And what is remaining here? 8v we have here. So now x value, all the values we have the value of the charge, we have the value for the magnetic field, we have the value for the x, all these values we have, and also we have the value for the potential difference. Now what I'm going to do, I'm going to substitute the value for getting the answer for the mass. So what is the value of the x? In the question they give the value of the x as 1.6254. So if you just need, you can just go back to the question and you can see the value. So I already know the values, so I just note down already. So the value of the x is 1.6254 square. Multiply the charge value is also given. So what is the value of the charge? 1.6022 multiply 10 power minus 19, and also the magnetic field is given as 80 millitesla. So 80 multiply 10 power minus 3 the whole square divided by 8 multiplied by the potential is you applied 1000 volt, right? So which is also given in the question. So now I have to find the value of the mass. So let's see what is the answer. 1.6254 square multiply 1.6022 10 to the power of minus 19 multiply 80 10 power minus 3 square over 8 multiplied by 1000. So I got the answer here as 3.3863 multiply 10 power minus 25 kilograms. So this is the answer. Now you have to give the answer in terms of atomic mass unit. So we just write the given. So what is given in the conversion given? So 1 atomic mass unit, which is equal to 1.6605 multiply 10 power minus 27 kilograms. So this conversion is already given in the question. You can just go back to the question part and you can see this conversion. Now I have to give the mass in terms of the atomic mass unit. So therefore the mass in terms of atomic mass unit, which is 3.3863 multiply 10 power minus 25 kilogram, and 1 atomic mass unit, which is equal to 1.6605 multiply 10 power minus 27. So let's see, and we can cancel this kilogram with this kilogram. So now I have to simplify this. So I have to just divide this number with this number. So let's see what is the answer. 3.3863 multiply 10 power minus 25 over 1.6605 10 power minus 27. So the answer what I got is 203.93 atomic mass unit. So this is the answer in terms of kilogram. So this is the answer in terms of atomic unit, atomic mass unit. Clear? This is the answer for this question. Thank you.